Hi guys, I just wanted to pick up on a couple of extra things, particularly cosine, sine rule, area of a triangle, arc sectors, that kind of stuff, okay? Um, but I want to start with this, if you don't mind, okay? Which is estimated mean, right? Estimated mean, again, it's not something that we've done for a little while. So with estimated mean, here's what you need to do. You need the midpoint of each group times the frequency. So for the first group, the midpoint of 0 to 5 would be 2.5 times 36. The midpoint of this group would be 7.5 times 58. At the end of all this, you will add up all of your answers. Now you can do this work at the side here, or you can do it down below in this area here. You'll add up all these, and whatever that is, you'll divide that. Well, how do we work at the mean? You add them all up and divide by how many there are. So you'll add up all of the phone calls that you've got there and divide by not how many numbers you've added up, but how many phone calls there are. That's a big mistake that people make. So we're going to divide that by 150. Now, I'll go back and I'll go to the solutions page. Okay. Let's have a look at the one I just did. Right. So it's a bit messy, and I don't like his kind of the way he writes that. Not for me. Not for me. Right. But this nonsense. Okay. But what he's saying is, okay, here's my midpoints. Midpoint of there, 2.5, 7.5, 12.5, etc. Then I'm going to times these together, which he's done here. Okay. Boom, boom. Add them all together and then divide that by how many, in this case, phone calls there are. Or if we take a look at a second one, same sort of thing, midpoints of each group. Right? If you're not sure how to get a midpoint, guys, right? What best way is to add. So if I didn't know what the midpoint of 191 and 197 was, I could add them, get an answer, and then split it in half, and that'll give you the midpoint. Or, for the bottom one, I could add them, just in case you're not sure, get the answer to that and split it in half, and that'll tell you the midpoint. Once you've got your midpoints, times them by the frequency, add your answers up, and divide that by, in this case, how many Christmas trees there are, which is 107, and put your answer maybe to one decimal place. That is that. Let me close those down. Okay, next little topic I want to talk about is arcs and sectors. Okay, I am going to jump straight to the solutions in this one, but I'm going to talk you through my version because he sometimes writes things slightly differently to how I would write them, okay? So, for example, this one will do me here, not a problem. This is quite a nice question for it. This one says, the area of the shaded sector is 65. The radius of the circle is 10. Find the size of the angle EOF, okay? So, this is the area of a sector, so I'm looking for pi over 360, and because it's an area, it's pi times the radius squared. Oh, I just called that pi, didn't I? Theta over 360 times pi times the radius squared. I don't know theta, okay? I do know the radius, but more importantly, I do know the answer. All right, so what we're going to do here, again, he's sort of not done it this way, is I would say that we can work this bit out. 3.14 times 10 squared, it comes to 314. Okay. The opposite of times in by 314 is to divide by 314. And the opposite of dividing by 360 is to times by 360. And then that will tell you what theta is. And I think it's to one decimal place, it becomes 74.5. Okay, he's written it as 74.484. I'd like one decimal place for me. Okay, there is a part B here. Part B says, okay, now that you know that angle, what is the length of this arc? Okay, so this is part B. What's the length of the arc? Well, now I know the angle 74.5. I'm not working backwards. I'm just plugging that in. But it's the length of an arc. So I don't want pi times the radius squared. I want pi times the diameter. The diameter is double the radius, which is 20. You can plug that straight into your calculator and you're done. Okay, so just be able to do arcs and sectors, hopefully forwards and backwards. By backwards, I mean if they give you an answer, hopefully you can plug in what you know and just shift it over. If it's a times, it's a divide. If it's a divide, it's times, and you can work out your missing thing. Okay? Right. Now, they could put an arc length or area of a sector in with an area of a triangle, which I kind of went through one in class. A little bit nasty if they do, but it could happen. I haven't found one on DIY Maths. I might come up with one on my own at the end. But for now, we need to get into the thing that most people I think are worried about here. The sine and cosine rule and trig formula. Okay. I'm going into this. Again, I'm not 100% on the way he writes things. Okay. However, in fact, so much so that I'm going to take the blank screen and we'll just go back and forth to show you the answers. Okay. Another reverse one. We just talked about a reverse area. Well, again, we're being told the area, this time of a triangle, not of a sector. So I've got to write the formula, put in the numbers I know, and move things over the other side, okay? For area and cosine rule, you need an SAS triplet. You need a side, an angle, and a side. That triplet there will allow you to work out this side using the cosine rule, or the area using the area rule, but both use the same information, okay? This is the area, so I'm going to be able, I'm not even going to read the question, I am going to be able to work out this side here because I actually know the answer to the area is 42.6, but I've got to get my labeling good, okay? So half AB sine C. So C is the angle, that's the capital letter, so that angle needs to become C. Even though it's labelled A on there, ignore their labels. Cross them out before you start, right? Well, actually don't do that in case it says find the length of AB and you won't be able to see what AB is because you've crossed them out. But they're not your labels, right? Opposite capital C will be little c, and it doesn't matter the other two, they just become A and B. So I am going half A, B, which I don't know, sine C equals 42.6. I would now put all this into your calculator. Half times 6.2 times sine 72. The only thing I would leave out is B. So you will end up with a number times B equals 42.6. So into my calculator, I've put half in brackets 6.2 in brackets sine 72, and I've put that answer there. Because that is times in the B, the opposite of times in the B is to divide whatever that is over there, whatever that question mark there is, okay? And that will tell you then what B is. Then the question actually says, find the length of BC, which is this here. Find the length of this here. It's the same triplet we need, but now this side becomes little a. In fact, if I change color, you'll see how awkward this is. It's almost something with redrawing it. This side becomes little a, this angle becomes capital A, and these sides become B and C. And we use A squared equals B squared plus C squared, which we know, right? Minus 2BC cos A. I'm not going to work this out again. I'm just going to put the numbers in. So B, we know is 6.2 squared. C, we now know is whatever our answer to there is squared, but we know it, but I just haven't got a calculator to work that out, okay? Minus 2, put B in there, put C in there, cos A, and we know A is the angle 72. Put that in your calculator, you will get an answer. However, what have we worked out? We have worked out what A squared is. We don't want A squared, we want A. Whatever that comes out to, we're going to square root it. So, chaps, that is how we use the SAS triplet to either use the cosine rule or the area rule. Slightly different labeling. For cosine, little a, capital A. For area, little c, capital C. Okay, now let's try and find a nice one in here with pairs. There we go. Too easy. Aha. Hopefully there's some pairs and stuff here. Let's have a look. Okay. Calculate the area of the triangle ACD. Okay, for the area of ACD, this is not the sine rule again, because look, I can see the triplet. Lovely, it's what I need, okay? But they don't want the area of that. They want the area of this triangle down here. This is the one they want the area of. So I'm going to need S. I'm going to need this side, this angle. Oh, I'm going to need this side as well as this angle. That's the triplet I need. So I'm missing a bit of information here, right? So to get that, I'm going to use the triplet and the cosine rule. So that would become little a, that would become capital A. These in any order become B and C, and I'll use a squared equals b squared, blah, 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 blah. And you're going to work out A. Once you know what A is, you then have all the information you need to use half AB sine C, and you're away. So hopefully we're all right now with these triplets. Okay, I'm now looking for an example without triplets, but with opposites. This will do. This will do. Okay, in here the question says find the length of DC. That's that. If we look, normally the thing that we need, we don't start in that triangle, we start in the other triangle because we'll have more information. But here, I don't have a triplet, but what I do have is a complete pair. And I also have an incomplete pair, okay? Where actually this would be really useful to me. Once I've got this on this triangle, I will then have a triplet, and I can use my cosine rule to work out there again, a squared equals b squared, blah, 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 blah. But let's have a look at the complete and incomplete pair, first of all, okay? Let me just check how long I've got left in this video. 3 minutes. I can do this in 3 minutes. It'll be a nice little short video then, okay? So for the sine rule, the pairs rule, you put the thing that you don't know first. So the thing that I don't know is the side divided by the sine of the opposite angle. There's the incomplete pair. And then I make it equal to my complete pair, which is the side, I don't know, sorry, my phone's going off here, and the sine of the angle opposite it. To find x, take that sine 82 up as a times, stick that in your calculator, and you're done. And like I said, once you then know that, you can use your triplet then and your cosine rule to find the other one. I'm interested in... What am I interested in? Oh, come on, I got 2 minutes. I can do this. Let's go back here. Okay. Ladies and gentlemen. No, too easy. No, it'll do. It'll do. It'll do. Find the size of DAB. DAB, this one here. Not enough information on this triangle. Let's go over here. What have I got over here? Oh, I don't have a complete and incomplete pair. I've got a triplet. Let me use the triplet to get this little a, right? Once I've got little a, I'm going to make it up. It's wrong. I'm going to make it up. I'm going to say that it's 15 centimeters. It's not, but just go with it, okay? What I will then go is go, okay, what have I got over here? Over here, I've got a complete pair and an incomplete there. But this time in the incomplete pair, it's the angle that I don't know. So I will write sine theta, because I don't know it, over its pair, which is 15, equals, and now I put the complete pair. But this time I'm putting the sine, the angles with the sines on top, and I'm putting the sides at the bottom. The opposite of dividing by 15 is to times that by 15. However, what I will then know is sine theta. I need to take that sine across. Anytime I'm finding an angle, I should be sine minus 1 in my answer. Now, hopefully that is good for you. With the last minute, I am going to just write something random that is nothing to do with sine and cosine rule, okay? Which is this. Exterior angles, just in case. All you need to know is exterior angles add up to 360 degrees. By an exterior angle, I mean this. So if I had a pentagon with 5 sides, that would be an exterior angle. To find it, I would do 360 and divide it by 5 because this was a pentagon. It becomes 72, right? If I want the interior angle, which is the angle inside the pentagon, we can see that they add up to 180. So I would do 180, take away 72, which is 108. If this was an octagon, 8 sides, Then the exterior angle would be 360 divided by 8, which is 45, I believe. Right? And the interior, I would then take that away from